Hello, everybody. Where am I? Hi, I'm Skip Alzheimer. Welcome to the AV Geeks Lunchtime Streaming Show, where we watch old 16mm films. And let me mute myself over here. Wait. Anyhow, that was the tail end of the Hoffman vacation trip to Florida from a giant reel. And so there might have been a little bit of overlap with what I showed yesterday, but they also might have visited similar places or driven past places. But anyways, I love me some home movies from the 50s. Really kind of fascinating look, especially because stuff from the 70s has a different look because usually they were using Ektachrome. So the colors are shifted different. And this was Kodachrome, which was just, of course, stunningly beautiful color. And then also what people are concentrating on are different. So anyhow, what are we watching today? We got a lot of stuff to watch. Let's learn about weather science with Pierrot and rain and snow.
Look at all the clouds. Celestine, do you see the pictures the clouds are making? Mm-mm. Juanita?
Uh-uh.
I see something. It's a cat.
I don't see a cat.
Where? There? No, it's all gone now. But look. There's the professor. The professor?
Where?
I don't know. Where did he go? Now that's a question mark, isn't it?
A question mark? Pierrot, where do you see a question mark?
Pierrot, I've got a question. How come you're seeing all these things in the clouds?
Yeah.
Sure, go ahead and laugh. All I know is I saw what I saw. How come clouds can do that? How come they can change their shapes like that? What are the clouds made out of anyhow? I'll go ask the professor. Professor?
Who's there?
It's me, Pierrot. Professor, could you tell me about clouds?
Clouds? Clouds? Clouds cause me nothing but trouble. Look how they get in front of my telescope. I can't look at important things in the sky when they're around. Clouds.
But Professor, could you please tell me what clouds are made out of?
Oh, certainly. Clouds are made of tiny drops of water. Would you like to see how the water gets into the air and forms clouds? Good. Now, you know that most of the Earth is covered with water.
The oceans.
That's right. Water from the oceans is always evaporating. Tiny bits of it are always rising into the air. When the sun warms the air rises and carries the water up with it higher and higher into the sky.
Hey, we're going up too. just like the water in the air.
Yes. Now, as the air goes up, it gets cooler. Cool air can't hold as much water as warm air can, so the tiny bits of water come out of the air and get bigger. They condense. They become tiny water drops that stick together and form a cloud.
I feel the water. I'm getting wet. And the air, it's cold.
But the droplets in the cloud are getting bigger and bigger, heavier and heavier. When they're too heavy to float in the air, they fall out of the cloud and down to the earth. That's called rain.
So that's how we get rain. Professor, the wind.
I know. It's getting stronger. We'd better go back down.
That was fun.
Yes, it was. Now, if you use your imagination a little bit more, we'll see where snow comes from. But we'll have to pretend that it's winter and the temperature where the clouds are is below freezing.
Ooh. Ooh. Okay, Professor. It's winter.
When it's cold, clouds aren't made of water droplets. Instead, they're made of ice crystals. Now look! Each snowflake was formed in a cloud. Tiny crystals of ice got bigger and bigger until they were too heavy to float in the air. Then they fell to earth as snowflakes. Snowflakes are crystals of ice that have 6 sides. They're shaped like hexagons, and everyone is different. No two are ever exactly alike.
So rain and snow both come from clouds. When it's warm, we get rain, and when it's cold enough, we get snow.
That's right, Pierrot.
Can we stop pretending it's winter?
Are you getting too cold?
Yes, I am.
I think we've used our imaginations quite enough for one day, Pierrot. It's much more pleasant being warm and enjoying the sunshine. There, that's much better.
Thank you, Professor.
Anytime. Well, back to work.
Goodbye, Professor. Goodbye. I know what I'll do.
Huh? What? Pierrot! My goodness, what are you doing up there?
I'm going to tell my friend Booty-Too all about clouds and rain and snow.
Oh yeah, leader lady. All right, so that was kind of interesting. It's barely animated, but I very much like the style, the illustration style of it's pretty cool. And that soundtrack, that synth soundtrack, was awesome. We'll have to see what YouTube flags later today to tell us what those songs were from. All right. Speaking of imaginary worlds, I don't think I've shown this. I couldn't find it in my spreadsheet of films that I've shown, so I apologize. Let me know if we've seen this. This is Fun with Words, from sentences to paragraphs. It's whacked out. Enjoy.
Then in a few hours we landed. We were in the best place in the world. Now, at long last, we were home. What are you doing? Finishing my story. What about? About traveling. I'm writing about an imaginary trip around the world.
You've never taken a trip like that.
Not really. It's an imaginary trip, and my story's an imaginary story.
What do you mean?
Well, if you concentrate and try to follow my thoughts, I'll take you to a whole world that I see in my mind. There, do you understand what I mean?
Oh!
And that's partly the idea of my imaginary trip. I set it up so we start out in our country, go all the way around the world, and come back home. How about that?
Can I see it?
Sure, here. What do you think?
I don't know. It looks hard to read.
What do you mean?
It's got something to do with the paragraphs.
The paragraphs?
Yes, look at your first one.
What's wrong with it?
Read it and picture what it says in your mind.
My parents and I finished packing. Then we went
There's your first problem.
What do you mean?
Your first sentence.
What about it?
I think the first sentence of a paragraph should make people think there's something special coming up.
Special?
Like this. At last we are ready to go. It gets people interested right away.
Oh, well, okay. At last we were ready to go. My parents and I finished packing. Then we went to the airport, got into a big plane, and took off for our trip around the world. First, we spent some time in Europe. And
Wait a minute.
what for?
Well, your paragraph started to be about setting out on a trip. But your last sentence was about Europe and how you spent time there. That's a different idea. It doesn't belong in the same paragraph.
Really?
Yes, all the sentences in a paragraph should go together.
What should I do?
Start a new paragraph.
All right. A new paragraph about Europe. I'll begin it with this first sentence about Europe. First, we spent some time in Europe. In London, England, we mixed with crowds of people. In southern France, we got suntans on the beach. Before I left home, I used to go to the beach sometimes.
Guess what?
I did it again?
That's right. The paragraph is about spending your time in Europe. So that sentence about going to the beach at home doesn't belong in it.
You mean I have to take it out?
Unless you start a new paragraph telling about your memories at home.
I'll take it out then. But even with it out, that leaves one more sentence in a paragraph.
Read it.
In Italy, we saw romantic old buildings and modern new ones. All right?
Sure. It's like the other sentences in the paragraph about seeing Europe. Now all the sentences in the paragraph belong together.
Yeah. What do I do next?
Move down to the next paragraph.
All right, let's see. The paragraph starts out. Then we traveled along the Rhine River, past some of the oldest castles in Germany. You know what?
What?
That's still about traveling through Europe. Shouldn't I put it in the paragraph before?
Of course. That's where it fits.
Then my next paragraph would be about Asia. It would start out. Asia seems strange to us. We saw dances and shows very different from the ones in our country. The first unusual thing we saw...
Wait a minute. Whatever's coming up, if it was the first thing you noticed in Asia, why didn't you put it first in the paragraph?
Oh, yeah. How do I do that?
By shifting the sentences around, like this. Asia seems strange to us. The first unusual thing we saw was a camel caravan going by. You see, it happened first, so you tell it first. We saw dances and shows very different from the ones in our own country. Sometime after that, we noticed that many rice farms were underwater. You see, it happened later. And now the sentences are in order, the order in which things happened in the story. Now let's see what's next. We thought the Philippine Islands in the Pacific were interesting.
Hey, you wait a minute. That doesn't belong there.
Why? The paragraph is about Asia, and the Philippines are part of Asia.
But that sentence starts a new idea. Read on and you'll see.
We thought the Philippine Islands in the Pacific were interesting because of the different kinds of people who live there. It does start a new idea about the kinds of people in the Philippines. That's the main idea, and it should start a new paragraph. Now, all the other sentences in this paragraph should be about the Philippine people, like this one. There are some people who live in the forest and have only the simplest tools.
That's about the people. I guess I wrote a pretty good paragraph.
So far. Let's see what's next. There are thick forests on the mountainsides.
Well, I guess that isn't about the people.
I guess not.
Maybe I'll take that sentence out?
Yes. Now read the next one after that.
Other Filipinos live on the coast and catch fish. But most of the people I saw live in cities like we do.
That's about the Philippine people. And did you notice the first sentence sets up the main idea for the paragraph? About people. Then the other sentences follow that idea. It's a good way to write a paragraph.
Yeah. Hey, there's another paragraph in my story.
Why not read it?
All right. Our trip around the world was nearly over. We were glad to be on our way back. I guess we were just plain tired. Then, in a few hours, we landed. We were in the best place in the world. Now, at long last, we were home. What do you think about that paragraph?
Well, the sentences are all about the end of the trip, and they seem to be in the order things happened. They seem to belong together, and the first sentence lets you know something interesting is coming up.
Then you mean it's good? You finally like one of my paragraphs?
No, there's something wrong.
I don't believe it.
Look at the lengths of the sentences. They're all about the same length.
So?
It's too much the same. It's boring. It might be better if some of the sentences were of different lengths, some short and some long.
You mean I have to write new sentences?
No, you can combine some of the ones you have already. Watch. Our trip around the world was nearly over, and we were glad to be on our way back. We were just plain tired. When we landed, I thought to myself that we were in the best place in the whole world. We were home. And that's the end of your story.
I guess it is.
But it's not the last time you'll have to think about writing paragraphs.
I guess not. And I guess it's about time we return to reality again. Thanks for sharing my imaginary world with me.
It was fun.
I'll try to remember what you showed me today. But if I can't remember everything...
Yes?
Can I show my story to you again?
It's like, yeah, we'll have this kid writing paragraphs about the Philippines. How can we make it interesting? Oh, well, we'll have it like in his imagination. Everything will be inverted and weird tinted and all that stuff. Yeah, all right, whatever. Okay, so this next film this kind of addresses some of the issues that I think that some of you have. It's called Know Your Clowns, and I'm guessing, I haven't seen it, but I'm thinking that it's probably related to, like some clowns are good and some clowns are bad. And so, oh, wait a minute. Okay, never mind. It's actually Know Your Clouds. All right. All right. Sorry. Not Know Your Clowns. Maybe there's a film like that that exists. Here we go. Know Your Clouds. Enjoy.
Electronic instruments. Violent turbulence can sometimes cause complete loss of control. Your weather flight problems will sometimes be associated with clouds of one type or another, and in order for you to anticipate these common sky objects, you must be able to identify them. Meteorologists all over the world recognize 10 basic clouds of distinct shapes, shades, and altitudes. This film will identify these 10 clouds with their symbols, show their altitudes, show how, when, and where they develop, describe their principal characteristics, and discuss their flight hazards, if any. All clouds are created by the condensation or sublimation of moisture in a cooling atmosphere. Whether this moisture steams from the spout of a boiling teapot or evaporates from a water surface. The moisture is first an invisible gas or vapor in the air. As this moist air is lifted in the atmosphere by vertical currents, the air gradually expands like a rising balloon. The expansion and cooling of this air continues. And then, rather suddenly, its invisible moisture condenses or sublimates into a visible mist or cloud made up of billions of tiny droplets of water or ice crystals. The temperature level where the cloud develops is called the dew point, and its Fahrenheit or centigrade reading depends upon the original degrees of humidity in the atmosphere. When air is damp, it may not have to drop very many degrees before it reaches its dew point. Dry air, on the other hand, may cool many degrees below freezing and not become saturated. Some of what we call weather comes about when large masses of air of different pressures, temperatures, and moisture content come together. In much of the USA, for example, there is frequent conflict between warm, moist air masses coming up from the Gulf of Mexico and cold, dry air masses coming down from the Yukon and other inland regions to the northwest. The boundary between these air masses where they come in contact is called a front. When neither air mass pushes the other, the front between them is called stationary. When the colder air mass retreats from the warmer, its trailing edge is called a warm front. When, however, the colder air mass pushes forward into the warmer, its leading edge is called a cold front. As a cold front advances, its greater density causes it to push in underneath the comparatively moist, warm air in its path and toss it into a sudden, upsweeping motion. As it rushes up into the sky, the moist air reaches its dew point level, then begins to condense. From this point on, it usually starts building up into the violent but beautiful thunderheads called cumulonimbus. The height of a cumulonimbus is closely governed by the altitude of the freezing level within the cloud, which is why it may rise up to as high as 50 to 60,000 feet during hot weather. And the higher it is, the more dangerous. Fortunately for those of us who fly, the outer limits of these atmospheric powerhouses are generally clearly defined. The furious up and down drafts of the cumulonimbus generally lead to short but heavy cloudbursts of large, drenching raindrops directly below its forward portion. Higher up in the cloud around the freezing line, they frequently produce hail, which, if heavy enough, falls to earth. In addition, static created by the turbulence soon builds up powerful positive and negative charges of electricity in segregated parts of the cloud, resulting in the multi-million volt discharges known as lightning. The forward part of a cold front, which usually moves from west to east or northwest to southeast, is like a giant broom sweeping the sky clean and leaving behind it clear, high-pressure atmosphere. Small, localized warm spots in the countryside may, however, create minor updrafts of air, resulting in the puffy white clouds called cumulus. There's a bump in each of these miniature thunderheads, but they are usually easy to avoid. When, however, these cumulus clouds form an unbroken rank, and it is necessary to fly through them, the safest, least turbulent altitude range is between 4,000 and 6,000 feet above the ground. Before we leave the cumulus family, we should mention that the sharply rising air currents and cauliflower clouds associated with cold fronts can also be created by air rising up the windward slopes of steep mountain ranges. When a warm front advances, it leans forward for several hundred miles. The warm air drifts up over the cooler, heavier air at a rather flat angle. Here we will see three high clouds. Cirrus is one of them, often called mare's tails. The cirrocumulus forms as flakes and is called a mackerel sky. Cirrostratus clouds may give the sky just a slight milky appearance. The altostratus is usually a bluish-white cloud letting through a weak, watery sunlight. The altocumulus forms into puffy white rolls. Nimbostratus is a thick gray, shapeless cloud that produces light rain or snow. Stratus is a gray cloud creating low ceilings and poor visibility. Stratocumulus is somewhat like a low altocumulus. Let's review these clouds and altitudes. Cirrus, above 20,000 feet. Cirrocumulus, above 20,000 feet. Cirrostratus, above 20,000 feet. Altostratus, 6,500 to 20,000 feet. Altocumulus, 6,500 to 20,000 feet. Nimbostratus, below 6,500 feet. Stratus, below 6,500 feet. Stratocumulus, below 6,500 feet. As the warm front advances toward the north, light rain or snow begins to fall from the altostratus and nimbostratus. The evaporation of light rain will often cause saturation and condensation that will lower the ceiling. Since the stratiform cloud is composed of small water droplets, rime ice can be a serious hazard. Icing can take place anywhere between 0 degrees centigrade and minus 20 degrees. Icing can also occur, however, in much colder temperatures because water in suspension has the property of supercooling down to as low as minus 40 degrees centigrade and yet retain its liquid globular form until something like the surface of a moving plane comes in contact with it and causes it to solidify. In the thinner, higher type of altostratus clouds, droplets of water can solidify on the leading edges of an aircraft without losing their globular or spherical shape, thus creating rime ice, which is granular in structure and therefore sufficiently brittle to shake off under the stress of flying. A good example of rime ice is the freezing substance which accumulates in the freezing compartment of the refrigerator when it needs defrosting. Calm wind, smooth flying, and continuous precipitation are characteristics of the stratiform clouds in addition to rime ice. Cirriform clouds are composed entirely of ice crystals. Therefore, no ice will form on aircraft while flying through these clouds. The cumulonimbus can be identified by its vertical development. Altocumulus and stratocumulus have a shadow between each roll. Cumuliform clouds have turbulence within them. In this cloud, clear ice will be encountered between 0 degrees centigrade and minus 10 degrees centigrade. Rime ice will form at temperatures below minus 10 degrees centigrade. Clear ice can also form if you fly using air and relatively warm rain starts falling from above. A good example of clear ice is an ice cube, which is very cohesive and difficult to break loose. So far in this film, we have related the formation of clouds to frontal conditions. Clouds also develop within air masses. When moist air flows over a warm surface, the bumpy cumuliform clouds tend to develop. On the other hand, moist air flowing over a relatively cold surface tends to create the horizontal stratiform cloud types. In summary, the atmosphere is an outstanding travel route with natural hazards such as severe turbulence, icing, and poor visibility, or just clear skies. Among all the many varieties of clouds, there are 10 basic types which are recognized internationally. If you learn to recognize these 10 cloud types and their symbols, you can avoid or minimize their hidden dangers. Let's review them. The stratocumulus is rippled in appearance. The altocumulus form into puffy white rolls. The altostratus is a bluish white cloud letting through a weak watery sunlight. The cumulus is a vertical type cloud with a flat base. The cirrus form into feathery white clouds, and from the ground they often resemble mares' tails. Stratus is a gray cloud, creating low ceilings and poor visibility. Cumulonimbus, or thunderhead, produces lightning, hail, and rain. The rare cirrocumulus forms in flakes or patches. The nimbostratus is a thick, gray, shapeless cloud that brings light rain or snow. Cirrostratus may give the sky just a slight milky appearance. By studying photographs, you can become familiar with the 10 basic members of the International Cloud Family. But the best way to know them is to see them with your own eyes, not only from the ground, but also from the air.
Clouds. So that was probably made by the Army Signal Corps or for the U.S. Air Force. Obviously, it's for pilots to try to figure out what they're flying through and what they should be aware of when they're flying through them. Interesting stuff. I think it's time that we introduce you to some shapes. And let me make sure I haven't actually shown this one yet. No, we haven't. Okay, introducing shapes, lines, and angles. Enjoy.
Everything we see has some kind of shape. An airplane has a certain shape. So has a doll. But these shapes don't have any special names. A shape that does have a special name is a wheel. A wheel has a shape like a circle. Let's trace the outline of the wheel. And now we have a circle. This is a musical instrument. It gets its name from the special shape that it has. It's called a triangle. And now we have a triangle. A book has a special shape, too. Its shape is called a rectangle. Each side of this block has a shape that is a special kind of a rectangle. It's the shape of a square. And so we have 4 shapes to talk about: a circle, a triangle, a rectangle, and a square. And when we're talking about shapes like these, we're talking about geometry. Let's use this pointing hand to help us learn about geometry. Did you know that a circle is made from a line and that the other shapes are made from parts of lines? They are. To see how, let's see what a line is. Follow the pointing hand. It's pointing to a dot. We can call the dot a point. Let's put another point here. And another, and another, and another. See what the points have made? A line. A line made up of points. A line is a set of points. So many points that we could never count them all. But what we have here is only part of a line. You see, in geometry, we suppose that a line has no beginning. And a line has no end. We have to think that a line goes on forever in both directions. Usually in geometry, when we say line, we mean a straight line. So let's make this curved line straight. We can give it a beginning here. Now we have just part of a line. And if we put an arrow on it here, like this, the arrow is a sign that the line really goes on and on. Now we have what is called a ray. 2 rays can begin at the same point. If we follow this ray down to the point where it meets the other ray, and then follow this other ray, we've marked an angle. The 2 rays are the sides of the angle. Now let's think of two more rays crossing the rays we have. We've made a shape, a square. One side of the square begins at this point, and it ends at this point where the rays meet. In geometry, we have a special name for the part of a line that is between 2 points. We call it a line segment. This line segment includes the 2 points, which are 2 corners of the square. Each of the sides of a square is a line segment. How many sides does a square have? Let's count. 1, 2, 3, 4. A square has 4 sides. Is there any side that's longer than the others? Let's take the square apart and see. These 2 sides are the same length. These 2 sides are the same length. All 4 sides have the same length. 4 line segments, all the same length, make up the sides of a square. How many angles does a square have? Let's count. 1, 2, 3, 4. A square has 4 angles, and each of these angles is called a square angle. There are 4 square angles in a square. Now remember that squares can have different positions. Now let's look for squares. A whole checkerboard is shaped like a square. And the board is made up of smaller squares. Brownies can have square shapes. So can a napkin. And tiles on a floor can have square shapes. Every square has 4 square angles and 4 sides that measure the same. A square is really a special kind of rectangle. How many angles does a rectangle have? 4. 4 square angles, just as in a square. How many sides does a rectangle have? 4. And each side is a line segment. But are all the sides the same length as they are in a square? This side is longer than this one. But this short side is the same length as the side across from it. And this long side is the same length as the side across from it. So in a rectangle, the sides that are across from each other measure the same. Remember, rectangles can have different positions. Now let's look for rectangles. The sides of many buildings have the shape of a rectangle. And so do doors. And window panes. Every rectangle has 4 sides and 4 square angles. But this shape doesn't. Remember, this is a triangle. How many sides does a triangle have? 3. And each of the sides is a line segment. And how many angles? 3. There's an easy way to change a rectangle into 2 triangles. Watch. Now we have 2 triangles, but there's something special about them. Look here. Remember, this is a square angle. Another name for it is a right angle. This right angle that was part of the rectangle is now part of this triangle. And so we call this kind of triangle a right triangle. The other triangle we made is also a right triangle. Do you see where its right angle is? Here. Some triangles are right triangles, and some triangles are not. Now, remember, there can be different kinds of triangles. and triangles can have different positions. Now let's look for triangles. See one here in this jack-o'-lantern? Its nose. A folded napkin can have a triangular shape. The front of this house has one. And in this bridge, we can find many triangles. Now, there's one more shape we've talked about, the shape of a wheel, a circle. A circle is made from a line, but it's not a straight line. It's a curved line, and it has no beginning and no end. It just goes on forever. And just like any line, a circle is a set of points. Let's start with a point here. Now we'll move a certain distance away and put another point here. If we mark many more points, all the same distance away from the center point, this is what we get. A circle. A circle is a set of points in which every point is the same distance from a center point. Now let's look for circles. Dishes have the shape of a circle. So have some clocks. Cookies can be shaped like circles on the outside or on the inside. And there are many other things that have the shape of a circle. What are the other shapes we've looked for? A triangle, a rectangle, and a square, which is a special kind of rectangle. We've learned that sets of points make lines, and that lines and angles make shapes.
All right. I'm having some curry ramen, and it is very strong. So spicy. That's the way I like it. Clears out the sinuses. All right, got another film on the scanner. This is the life story of a hummingbird. Enjoy.
This motion picture is unusual because the incredibly tiny hummingbird, although unafraid of ladders, lights, and cameras, is difficult to photograph. Its movements are often swift and sudden. The hummingbird is the smallest of all birds. It averages 4 inches in length. How much do they weigh? It may take 15 fully grown hummingbirds to weigh 1 ounce, and this mature female barely counterbalances a nickel. By means of high-speed photography,
You can now see the hummingbird's wings in slow motion. The wings change pitch at the shoulders to provide lift at each stroke, much like the hands of a swimmer. This unique figure-8 movement enables the hummingbird to remain suspended or to fly backward as well as forward. This maneuverability enables it to feed in flight from nearly any position. The hummingbird is the only bird which can fly in any direction. Although its wings appear to be moving slowly, they are beating more than 60 times each second. Many hummingbirds are beautifully colored, especially on the throat and head. Colors are always more brilliant in the male bird. This color is caused by iridescence. The feathers contain no color pigment. They're not pigmented like this fruit, but reflect colored light, like a prism or the facets of a jewel. Therefore, movement contributes to the illusion of color, and the colors seem to wink on and off, and even change hue as the bird turns its head from side to side. Its tongue is long and sticky and perfectly adapted for extracting pollen and nectar and tiny insects from flowers. A hummingbird feeds as often as 50 times a day and investigates everything in its search for food. Since it's attracted by bright colors, it can be lured to your hand by colored water and will drink if the water is sweetened with sugar. Why does a small bird eat so much? Hummingbirds live in nearly every part of North and South America. This is a female Calyptiana from the Pacific coast of California. It is more often called Anna's hummingbird. And this is the male Calyptiana, one of the few hummingbirds which sing. He courts the female like this. Courtship continues with an extraordinary display by the male. While the hen waits, the cock flies skyward. She watches from the ground. The cock flies higher and higher until he's almost out of sight. Then he dives. What the female hears is the sound made by the cock's outer tail feathers. Listen carefully as he dives again. During such a dive, the cock may reach a speed of 60 miles an hour. On his return to the ground, the cock pursues the female until she accepts him as her mate. The nesting season for Anna's hummingbird begins in December and lasts through August. Normally, the Anna builds several nests each season. In a single day, she makes more than 150 trips for nest building material. She builds her nest with greater care than many birds, fitting each bit of material into place and shaping it with her body. Twigs and grass, feathers and spider webs, and pieces of lichen are all skillfully woven together like this. Then she lines the nest with the softest material she can find. In this case, the female uses cotton from a clothesline rope and packs the lining layer on layer with her feet and body. The task of fitting and lining requires hours of patient effort before she is finished. The entire project takes almost a week. The result is a soft, warm nest about the size of a walnut shell, or just spacious enough for a bumblebee. The hen has now been nesting a week. On the 7th day, she leaves the nest and the first egg. For most of the day, she guards the egg. She feeds briefly, but at dusk returns to the nest to protect her egg from the cold. She covers it each night for the next 2 nights. In the morning of the 3rd day, she lays a second egg. Normally, 2 eggs are all she will lay in a single nesting. The incredibly small scale of a hummingbird's world is revealed by this small beam. Inside each egg is a chick embryo. With a normal appetite for about 50 meals a day, the female's incessant need for food forces her to leave the eggs exposed frequently, but only for short periods of time. She feeds during the daylight hours, when the eggs will maintain a safe temperature. Each time she returns to the nest, she brings new material for repair. Instinctively, she keeps the nest strong and warm. For a bird so small, a storm means danger. A cold, beating rain is a hazard which could destroy her eggs. Incubation can last from 12 to 18 days. Incubation is the time between the laying and the hatching of the egg. Why does the time required for incubation differ with each egg? Her first egg is ready to hatch on the 15th day. And the first chick hatches while she hovers over the nest. She does not feed the chick immediately. When the chick is free of its shell, she covers the nest and incubates her second egg. Not until 2 hours later does she feed her hungry chick. As with most newly hatched nestlings, the chick receives pre-digested food. In this way, she nurses her nestling until its digestion can accommodate a normal diet. At this critical time, she must not neglect her second egg. On the 16th day of incubation, the second egg hatches. Now she has 2 ravenous appetites to satisfy. As before, she watches the chick during the hatching. She does not assist. She makes sure it is safely clear of the shell, then turns all her attention to the feeding of her young. Now that her chicks are hatched, she has neither time nor energy for careful housekeeping, so she clears the nest of shells with her wings. The nestlings are helpless. Their eyes are closed, And in the first days after hatching, they require countless feedings. Their diet continues to be pre-digested, their hunger perpetual. They also demand the warmth of her body. After a week, the nestlings have enough feathers to protect them from the cold, and their eyes are open. 2 weeks after hatching, they crowd the nest. This is their progress in just 14 days. Their beaks grow longer, and by the time they can fly, they will be able to feed from flowers. Covering the nestlings is now difficult. Since she can find no room for herself, she leaves the nest. For the first time since hatching, the chicks are alone in the nest at night, while the hen takes an undisturbed rest, her feathers fluffed against the cold. To the chicks, rain is strange and uncomfortable. But the hen no longer gives them protection. "17 days after hatching, the chick's back is covered with iridescent feathers. Thus far, they've been totally dependent on their mother. Now the fledglings begin to exercise their well-feathered wings. Unlike most birds, they practice flying before they leave the nest. The mother waits. To get the fledglings to fly, she first feeds them. Then she leaves them while they're still hungry. She flies above them. She uses food to tempt the chick higher. Her second fledgling lags. But hunger is a strong incentive. And the need for food is continuous. You have seen the life cycle of the hummingbird, smallest of all birds. Next spring, when the chicks are old enough to mate, the life story will begin again.
Wow, beautiful footage. Beautiful footage. So that was obviously struck on what we call low fade. Let me stop this. It came from, a nice negative. So they restruck it instead of putting it on I'm sure there's copies of this that were on Ektachrome that were faded beat to red, but that one was beautiful. And we learned so much about hummingbirds. Anyways, thanks for joining us today. Very much appreciate it. Tomorrow is supposed to be gross again, so who knows what's going to happen. But I'll be here. What else? Where else do I got to go? Thanks for tuning in. If you like what you saw, please hit the thumbs up button, hit the like button, subscribe. Keep telling these algorithms that what we're doing here is fun and entertaining, and it should be suggested to lots of other people. You can also donate via the Super Thanks button, or go to ko-fi.com/abgeeks or patreon.com/abgeeks. Those are great ways to support us as well. Everybody have a great rest of your Thursday, and we will see you soon. Take care.